The first question, check whether the vectors 1, 0, 0, 1, 1, 0 and 1, 1, 1 are linearly dependent or not. We have to check these vectors are linearly dependent or not. So, the first vector, we named the first vector as x1, this x2 and this one x3. These are the three vectors. First I am writing the matrix form. Matrix form of vectors is, let A is equal to, I am writing in the matrix form, so we have to write the first vector as the first row, that is 1, 0, 0. Okay, now x2 as second row, that is 1, 1, 0, and x3 third row, 1, 1, 1. Okay, now we have to reduce this in echelon form. Okay, so we all know how to reduce this as echelon form using elementary transformation. We have studied in the last class. Okay, so we have to reduce this matrix to echelon form. For that we have to make all the elements below the principal diagonal as zeros. Okay, so we have the first step is we have to make these two elements as 0. For that we have to, what is the transformation? R2 minus R1, we get 0 here. R3 minus R1, we get 0 here. But I am taking here x1, x2, x3 instead of R1, R2, R3. Okay, so here it is equivalent to 1, 0, 0. Now this is x2. So x2 is equal to x2 minus x1 and x3 is equal to x3 minus x1. These are the two transformations. But when we subtract x2 from x1, we get another x2, another row. This row changes. Okay, when we subtract x2 from x1, we get another row. That is, this row changes to another row. So I am naming it as x2 dash and this also x3 dash. We are doing the same procedure as in the row reduced echelon form. The name only changes. So the changed row I am named as x2 dash and here it is x3 dash. So this becomes here 0, 1 minus 1, 0, 1 minus 0 is 1, 0 minus 0 is 0. Here 1 minus 1 we get 0. Here 1 minus 0, that is 1, and 1 minus 0, that is 1. Okay. Now the next step is we have to make this element as 0. So we have to subtract x2 dash from x3 dash, that is x3 dash minus x2 dash, we get 0 here. So this is equivalent to, first row is 1, 0, 0, second row 0, 1, 0, and I am subtracting x3 dash minus x2 dash. So we get another vector, the new vector I named as x3 double dash. Next vector, x3 dash becomes x3 double dash equal to x3 dash minus x2 dash. Okay, that is 0. Here 1 minus 1 is 0 and 1 minus 0 is 1. Okay, our reduction completed. Look at this 1, 1, 1. No element is here under this one. So our row reduced echelon form completed, and now we have to check how many 0 rows are there in this matrix. Is there any 0 row? No. All the row contains at least one non-zero row. If there is 0 row, then these vectors are said to be linearly dependent, otherwise independent. Okay, so these vectors are linearly independent, not dependent, because there is no 0 row. So these vectors are linearly independent. So there is no 0 row. There is no 0 row. Therefore, x1, x2, x3 are linearly independent. Linearly independent. So, very easy method. Linearly dependence and independence. Okay, thank you.